Mellin transform of Si of x, basically small si of x. This is just an alternative kind of sine integral, and its definition is small si of x is negative of integral from x to infinity of sine t or by t dt. The negative sign over here is because if we put a negative sign over here, the derivative of the si of x will again just be sine x by x. So if it was not the negative sign over here, here would be a negative sign. So that's why it's put over here. Yeah. Now with this definition, let's try to solve this integral. Integral from 0 to infinity. Also, please know the Mellin transform of sine function. Yeah, I do hope you most of them know it. The Mellin transform of sine function, sine of t, is just gamma as by sorry, this is not gamma as by sine pi s by 2. Yes, and similarly our Mellin transform of if it's sine at, its Mellin transform is just 1 by a to the power s gamma of s. Sorry, why am I writing f in terms of gamma of s sine pi s by 2. Yeah, and if you don't know what Mellin transform, basically Mellin transform of a function, let's say f of x, is just integral from 0 to infinity of x to the power s minus 1 f of x and then dx. So these are some things that you need to know that we will use in this video. Yes. Now let's solve this integral. We basically have x to the power alpha minus 1. Yeah, and this si function is now a negative of integral from x to infinity sine t by t dt. Yes. Now integral from 0 to infinity, integral from x to infinity, x to the power alpha minus 1 sine t by t dt. Yes. And now the next thing that we might want to do is the following thing. If we let y as, let's say, t by x, let us see what happens in that case. So basically I want to change the limits to numbers. Yeah, integral from 0 to infinity, integral from 1 to infinity. Now over here, since we have x to the power alpha minus 1, we will have x is basically, okay, let's not change the x because x, let it be as it is. Yeah, basically we are changing in the world of t, so x is just a constant right now. X to the power alpha minus 1, and now sine of t is xy by t is xy. And also I've forgotten a dx over here because at last there should also be a dx. Yeah, I've forgotten dx, and yeah, here also dt is equals to x times dy and then dx. Yes, and now the x cancels out, so we have negative of integral from 0 to infinity, integral from 1 to infinity, x to the power alpha minus 1 sine of xy by y dy dx. Yeah, now if we interchange dy and dx, basically this limits of integral, we'll be able to solve other integral using Mellin transform. Yeah, so that's why let's do that. 1 to infinity integral, and then let me take the 1 by y outside, and then 0 to infinity, and then x to the power alpha minus 1 sine of xy and then dx dy. Yes. And then now minus integral from 1 to infinity and then 1 by y, and now this is just 1 by x to the power alpha, because x is the constant. Yes, no, I think y is the constant. Sorry. Y is the constant for this Mellin transform. So y to the power alpha, and then gamma of alpha by sine pi alpha by 2, and then dy. Now we can take these other things outside, and so we get minus gamma of alpha sine of pi alpha by 2 integral from 1 to infinity y to the power minus alpha minus 1 dy. Yes, now let us take its integral, and then we get minus gamma of alpha sine of pi alpha by 2. Over here it's y to the power minus alpha by minus alpha from 1 to infinity. Yes, and then we get minus gamma of alpha sine of pi alpha by 2, and this is 0 plus 1 by alpha. Yes, so now finally we get the answer. Answer is minus of gamma alpha by alpha sine of pi alpha by 2. So this is the Mellin transform of the small si of x function. Yes, yeah, that's correct. And to talk about the flow of the solution, we basically just use the integral definition of the si function, and then where the limits to be on numbers, interchange the integrals, use the Mellin transform, and that's got solved. This was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.